Hello everyone, welcome to the class of Financial Institutions and Capital Markets. Today let's continue with Chapter 6, Bond Market. So in the first class we discussed an overview of the bond market. So basically we introduced three main types of bond: the treasury bond, municipal bond, corporate bond, and then we discussed the compensations of the national debt, and then we emphasized that all the treasury securities, including treasury notes, treasury bond, are all semi-annual compounding, means that they pay coupon interest every 6 months. So this is what you always need to keep in mind whenever you do calculations. And then the most important part of the first class in Chapter 6 is you need to know how to calculate the yield to maturity. So this is just a simple time value of money calculation. The only thing you have to be very careful is that always remember to use semi-annual compounding. And then after that, strips is the kind of the other most important, the second most important topic in the first class. You know how strips are working. Basically, it's just each cash flow becomes a product. So separate all the cash flows associated with a treasury bond, and then make them strips. And then, so basically means that, and again, the key thing here, probably I forgot to mention, in the first class when we were in this page, I was asking you whether you noticed there, here if you use 7.9 as the interest rate, you won't be able to get this result. The secret is that do not use 7.9 because this is annual interest rate. So you have to use the semi-annual interest rate, which means 7.9 divided by 2. Then also change the maturity into a number period, means that number of 6 months. So therefore you will be able to get this present value if you use semi-annual compounding. And then so strips is the most important part. So basically, you know that if you have a future cash flow, you know how to design a purchase plan of the strips in order to meet your future demand of cash. And then you know how to calculate the price of each strip based on the future cash flow, and then you know how many shares should you buy to meet your future cash flow. So this is strips. So today is our second class of Chapter 6. In today's class, there are mainly three main topics that I want to discuss. So the first one is the accrued interest, and the second one is TIPS, that's Treasury Inflation Protection Security, and then the third one is the before and after tax yield. So we're going to discuss them one by one. So first, let's basically review what we have learned before. So how to do a bond valuation. This is the equation for the bond valuation. Again, this is not very practical because we're not going to use the equation to calculate the fair price of a bond, but this is just for you to understand the logic behind it. So bond value calculated from the following formula is the price referred to as the clean price quoted in the financial process. So you see here, VB is the present value of the bond, INT is the interest payment, and this is the interest payment like per year, so annual interest payment. And then small m, lowercase m is the number of times per year interest is paid, usually m equal to 2 if it's semi-annual compounding, right? So then INT over m is the payment received in each period. And then RB is the interest rate used to discount each cash flow in the bond. Again, this is annual interest rate, so to use the periodic interest rate, you have to use RB divided by M. and then therefore the number of period is going to be M times N. N is the number of years until the bond matures, and M is the number of period within the year, right? So this is the equation for it. So basically you have to discount all the cash flows. So that's why this equation has two parts. The first part is just the discounting of all the interest payments, and then the last part is the discounting of the principal value, the face value. So here's an example. We're not going to use the equation that I showed you in the previous slide, but we are going to use the financial calculator to calculate this one is calculating the price of the bond, which means the PV, right? So in other words, you will have to try to find out the values for the other four variables. This question says, in the previous table, look at the treasury note outstanding on Monday, May 23rd, 2016, or on settlement date of Wednesday, May 24th, 2016, with maturity on November 30th, 2017. So we can go back to the table and find this one that matures in November 30th, 2017. It's in this table. Matures in November 30th, 2017, right? So which one is that? Oh, it's this one. I don't know whether you can see my. It's the fourth one in the second panel under treasury note stripped principal. Yeah, so that's the fourth one there. So based on that one, because the table was showing you the data on May 23rd, and settlement would be the next day, which is 24th. So till November 30th, 2017, there are about 1.523286767 years from maturity. So how do you get this number? You calculate the number of days left and then divide it by 365. But I know that you probably are thinking, even calculating the number of days left is not that easy, right? So don't worry. In the quizzes, in our quizzes, I'll always make sure I'll calculate this number for you. So I'll tell you how many years is left from the maturity. Therefore, you don't have to count the days yourself. Yeah. So basically, this 1.523 years from maturity is the number of years, but because this is treasury note, so we have to use semi-annual compounding. Therefore, we have to use this 1.5232867 times 2 in order to get the number of period. And the treasury note had a coupon rate of 0.625% and an asked yield of 0.853%. So using the bond valuation formula, what is the asked price of the bond? Well, you can use the formula, but I think the easier way is just to use the financial calculator. So therefore, we know the N, that is 1.5232867 times 2. We know the coupon rate is 0.625 times the face value. Let's say it's $1,000. Therefore, the annual payment is going to be if it's $1,000, then the annual payment is going to be 6.25, right? Divided by 2, then we get wait, if it's okay, let's say if it's $100 face value, then times is 0.625%, you get 0.625 dollars annual interest payment, right? Yes, and then divided by 2, then you get the payment in every 6 months. So this is PMT, and then yield is 0.853%, but this is annual payment. Therefore, we have to divide it by 2 to get the semi-annual interest. So this is I/Y, and then FV in this case is going to be $100. Therefore, we can calculate the PV. Yeah. So basically this is how to calculate it. If you use equations, that's possible to calculate, but I think it's too much work. So financial calculator is way much easier. So this is the answer for it. Okay, so next let's discuss our first topic today, or the most one of the first the first one of those three important topics today, that is accrued interest. So accrued interest, portion of the coupon payment accrued between the last coupon payment and the settlement date. It is paid by the buyer to the seller if the treasury note or treasury bond is purchased between interest payment dates. And so this is accrued interest. And the purchase price of the treasury bond or treasury note plus accrued interest is called the full price or the dirty price of the security, while the price without accounting for accrued interest is called the clean price. So in other words, the dirty price equals to the clean price plus the accrued interest. Accrued interest is just the part of the interest that you haven't yet received but you deserve. Yeah, because you haven't yet reached the date of the interest payment, but you have already waited a number of days or a number of months. So therefore you are entitled to have that part of the interest, although you won't be able to wait until it pays you. Therefore you have to be compensated by the buyer of the treasury note or the treasury bond. So accrued interest on the treasury note or the treasury bond is based on the actual number of days the bond was held by the seller since the last coupon payment. Yeah, so it's basically just you deserve the proportion that you have waited for, right? So usually you have to wait like 160 days or 6 months to get paid. But if you hold the bond for at least like 90 days, at least half of that time, and then you sell it, if they don't pay you that part of the interest, then it's not fair for you, right? So you have to be paid at least half of the interest for the 90 days that you have waited for. So accrued interest equals to the interest payment, that is annual interest payment, divided by 2. So this is payment for 6 months, and then times the proportion that the seller has held for the coupon payment. So the actual number of days since last coupon payment divided by actual number of days in coupon period. Yeah, so this is accrued interest. Here's an example of the calculation of accrued interest and yield to maturity on the bond to help you understand it better. It says on August 5th, 2019, you purchase a $10,000 treasury note that matures on May 15th, 2025. The settlement occurs 1 day after purchase, so you receive actual ownership of the bond on August 6, 2019. The coupon rate on the treasury note is 5.875%, and the current price quoted on the bond is the financial price is the 101.3437. The last coupon payment occurred on May 15, 2019, that is 82 days before settlement, and the next coupon payment will be paid on November 15, 2019, that is 102 days from settlement. We illustrate this timeline in figure 6/4. The accrued interest due to the seller from the buyer at settlement is calculated as this, right? So this is the annual coupon interest rate divided by 2. Therefore, this is like semi-annual coupon interest payments, and then times the proportion of the days that has been held by the seller, which is 82 days, divided by 184, right? Because they already held it for 82 days, and then there is still 102 days left from the settlement, which means in total this period is 184 days. need to point out here is that although this equation is correct, but this number is wrong. It's actually not 1.3251. It's supposed to be 1.3091. I don't know why it made this mistake, but I copied this sum directly from the textbook, so I didn't change it. Just also to let you know that there's a mistake in the textbook. So, but yeah, the correct number should be this. If you times the face value, then it should be $130.91. So therefore, this is the accrued interest part. Then you also calculate the clean price, which is well, you don't have to calculate it. It's already given it to you here. So this is the price. So the accrued interest plus the price equals to the dirty price. So the dirty price of this transaction, or the full price paid by the bond buyer, would be this clean price plus the accrued interest equal to dirty price. So that means it's 102.6528% per 10,000 face value bond. Yeah. So here is a timeline of the accrued interest in the previous, not in the previous example, but another example. So you see that, well, it's actually, no, wait, it's a different example. Well, it's actually the same, no, yeah, it's the same, sorry, it's the same example. Period is 184 days. So basically means that from the last coupon payment to the next coupon payment date, it's exactly, or in total, 184 days. But the bond was sold on the August 6, but then considering the settlement, that takes 1 day, so we consider August 7th as the bond settlement date. So basically that means there are in total 83 days in the first part, and then 102 days in the second part. But technically the bondholder only held the bond for 82 days, because there's 1 day for the extra settlement, right? So we don't consider this 83, instead we consider it as 82, and then divide it by the total number of days, which is 184. Therefore you'll get the answer. Yeah. So here's another example. I put in a lot of exercise or example questions here in this chapter to help you better understand the material. And all these example questions are important because you notice that I usually don't add too many questions in the homework, but sometimes I would use the questions from the slides and change some numbers here and there, and then put them in the quiz. Yeah, so it's important to not only finish your homework, but also have a careful look at the questions I included in the slides. So in this exercise question, it asks, on September 1st, 2012, an investor purchases a 10,000 par treasury bond that matures in 12 years. The coupon rate is 6%, and the investor buys the bond 70 days after the last coupon payment, which is 110 days before the next one. The asked yield is 7%, so it's asking you what is the dirty price of the bond. When you see dirty price, you know that, oh, dirty price equal to clean price plus the accrued interest. So that means there are 2 steps to calculate in this question. The first step is to calculate the price, and then the second step is to calculate the accrued interest. For the price, it's relatively straightforward. It's a treasury bond, so always keep in mind we have to do semi-annual compounding. Therefore, the price, to calculate the price, we need to know n, which is 12 times 2 equals to 24. And then payment is 6% times the face value, which is 10,000, so that is 600, right? And then divided by 2 for 6 months. The payment is $300, and then that's PMT. And then the yield, the asked yield is 7%, so divided by 2, that's 3.5. That's I/Y. And then face value is $10,000. Therefore, we can calculate the present value. So that's the first step. And then after you calculate the present value, the next step is to calculate accrued interest. Accrued interest is just like the interest for 6 months, which is $300 as we calculated before, right? Times 70 divided by 70 plus 110, so that's 180. So 70 divided by 180, then that's the accrued interest. So add up those two parts, then you will be able to get the dirty price. So this is the result. You see, first calculate the price. I/Y is 7 divided by 2 equals to 3.5. N is 12 times 2 equals to 24. PMT is $300, and at future value is $10,000. Well, here I put negative in order to get a positive price, but I actually believe in actual sense it should be positive, right? That's the payment you receive. Therefore, if both are positive, then this number should be negative. Yeah, it's just be careful. These two have to be the same sign, because these represent the money you receive, right? So if you decide to put them positive, they're both positive. If you decide to put them negative, they're both negative. They can't have the opposite sign. Yeah, and then this is the number, this is the price. And after you get the price, calculate. The second step is to calculate accrued interest. It's $300 for 6 months, then times 70 divided by 180 is 180 equals to 70 plus 110. Yeah, so this part is the accrued interest. And then you add up these two parts, then you get the dirty price. Yeah, this is the result. So basically that means C is the correct answer. Yeah. So that was the accrued interest. Basically, that's the first topic for today's class. The second topic I want you to know after finishing today's class is the TIPS. The full name is called Treasury Inflation Protected Securities. The key thing for TIPS is that we have to adjust principal based on the inflation rate. Yeah, so remember, principal is no longer the face value. It's inflation adjusted face value. That's the key thing. So, but let's have a look at the background of or introduction of the TIPS first. In January 1997, the U.S. Treasury began issuing inflation-indexed bonds called Treasury Inflation Protected Securities, in other words, TIPS, which provide returns tied to the inflation rate. The outstanding value of TIPS was over $1.4 trillion by June 2019. Unlike the fixed principal bonds, the principal value of a TIPS bond can increase or decrease every 6 months by the amount of U.S. inflation or deflation as measured by the percentage change in the CPI. So it is used by investors who wish to earn a rate of return on their investments that keeps up with the inflation rate over time. Yeah, so that's the meaning of TIPS, why TIPS was created at that time. Here's an example of how to calculate the inflation-adjusted principal value or face value. So to see how TIPS bonds work, consider an investor who on January 1st, 2022 purchased a TIPS bond with an original principal of $100,000, a 4% annual or 2% semi-annual coupon rate, and 10 years to maturity. Yeah, so this is the information of the TIPS. The inflation-adjusted principal at the end of the first 6 months on June 30th, 2022 is found by multiplying the original par value, which is $100,000, by the semi-annual inflation rate. Thus, if the semi-annual inflation rate during the first 6 months is 0.5%, the principal amount used to determine the first coupon payment is adjusted upward by 0.5%. So that means the face value now becomes, after the first 6 months, the face value now becomes $100,000. This is original face value times 1 plus 0.5%. So that's 1.005. Yeah, therefore, the first coupon payment paid on June 30th, 2022 is calculated as this adjusted face value times the coupon interest payments for semi-annual coupon interest payments, right? So 2%. Therefore, this is the first coupon payment for the for the first 6 months. The inflation-adjusted principal at the beginning of the second 6 months, therefore, is $100,500, right? So this is after the adjustment in the first 6 months, which is the beginning face value in the second 6 months, right? The face value in the beginning of the second month. Suppose that the semi-annual inflation rate of the second 6-month period is 1%, then the inflation-adjusted principal at the end of the second 6 months and the principal amount used to determine the second coupon payment is adjusted upward by 1%. Yeah, so that means you use this beginning, the face value in the beginning of the second month times 1.01. So 1 plus 1%, that's 1.01, right? So this is the face value. This is the adjusted face value for the second 6 months, in the end of the second 6 months. Therefore, the coupon payment to the investor for the second 6-month period is inflation-adjusted principal on the coupon payment date, which is $101,505 times the semi-annual coupon rate, which is 2%. So that's this equation. Or on December 31st, 2022, the investor receives a coupon payment of $2,030.10. So that's tips. That's an example of tips, right? So the key thing here is to remember you have to adjust the principal every 6 months based on the inflation rate. The spread between the yields of tips and non-tips is the same maturity is the market's consensus estimate of average annual inflation over the period. Yeah. So the only difference is the whether if it's the same maturity, then the only difference is whether the face value is adjusted based on the inflation rate or not, right? Therefore, the spread depends on the estimate of the inflation rate over that period, and the yields of tips are usually lower. Yeah, and further, the periodic principal adjustments are taxable as interest. Yeah, so why is it lower? It's mainly because you are already it already protects you against inflation, right? So therefore the yields, remember the equation that we discussed before for the required rate of return. In the required rate of return for the tips, we no longer need to include inflation premium, right? Because the face value is going to be adjusted based on the inflation rate. So therefore the yields are going to be lower because it bears less risk. The risk that tips are not bearing, while other non-tips securities are bearing, is the inflation risk, right? Yeah. So consequently, tips may not be an appropriate investment for someone looking for significant current income because it usually gives you lower return, and also it's taxable as interest. Yeah. So this slide introduces the primary and secondary market trading in Treasury notes and Treasury bond. So U.S. Treasury sells Treasury notes and Treasury bond through competitive and non-competitive Treasury auctions. Auction is a single price auction. That means all bidders pay the same price, which is the price associated with the highest of the competitive yield bid. At each auction, non-competitive bids are filled first. Next, competitive bids are ranked from the lowest to highest yield. That means the bidder willing to accept the lowest yield is willing to pay the highest price. And coupon rate of the auctioned notes or bonds is the stop-out yields rounded down to the nearest 1/8%. Most secondary trading occurs directly through broker and dealer trades. The next, that page is not very important. I didn't highlight anything. You can just have a look at it. Then the same for the municipal bond. It's the only difference between municipal bond and the Treasury securities is municipal bond are issued by the state or local government, while the other one is issued by the federal government, right? So local government usually issue municipal bond for to raise fund to fund imbalances between expenditures and receipts, and finance long-term capital outlays. But municipal bonds are attractive to household investors because interest is exempt from federal and most state and local income taxes, while Treasury securities are only exempt from state and local income taxes, but not the federal taxes. Yeah, so therefore, municipal bond is more attractive compared to the Treasury securities, right? The difference is the federal income taxes. There are two types of municipal bonds. The general obligation bonds, which is called gold bonds, are backed by the full faith and credit of the issuer, and the revenue bonds are sold to finance specific revenue-generating project and are backed by the cash flows from that project. So, but you see, most of the bonds are actually revenue bonds. Well, it takes bigger market share than the general obligation bond. But this part you can just also have a look at it. It's not very important. Here is an exercise question for the municipal bond. It's a true or false question. It asks, revenue bonds are backed by the full revenue of the municipality. True or false? Yeah. Be very careful. This one sounds correct, but it's actually wrong or incorrect because it's not the full revenue. It's the revenue of a certain project. Yeah, so remember, we can go back and see the revenue bonds are backed by the cash flows from that project, not the full revenue. Yeah, so it's false. Okay, so this part is the last topic of today's class, is the before and after tax yield. Yeah, so the after tax or equivalent tax-exempt yield on the taxable bond can be calculated as follows. So after tax yield equals to before tax yield times 1 minus t. Right? So this is before tax and then times 1 minus t equals to after tax. Totally makes sense, right? Therefore, then you can rewrite this equation and put before tax in the left-hand side of the equation, then you get RB equal to RA divided by 1 minus t. So the yield on the tax-exempt municipal bond can be calculated as follows. Yeah, the before tax yield on the taxable bond equals to after tax yield divided by 1 minus t. Yeah, here's an example for you to understand this before and after tax yield. Suppose you can invest in taxable corporate bonds that are yielding 10% annual interest rate or municipal bonds. If your marginal tax rate is 28%, which is the sum of the federal, local, and state taxes on the last dollar of interest income, then what is the after-tax or equivalent tax-exempt yield on the taxable bond? Yeah, so this is before tax. Yeah, so you have two options. You can either invest in this before tax or taxable corporate bond, which gives you 10% yield, or a municipal bond. The municipal bond doesn't charge, you don't have to pay taxes, right? So this one is like, you can earn lower yield, but because you pay less tax, therefore you don't have to, you don't need to have the same level of rate of return to have the same after-tax yield, right? So therefore, if this is before tax and the tax rate is 28%, then what is the after-tax yield? That's very easy. Just 10% times 1 minus 28%, right? So it's 7.2%. So that means investing in this taxable corporate bond that gives you 10% rate of return is equivalent to investing in a municipal bond that gives you 7.2% yield, because for the corporate bond you have to pay 28% tax, while the municipal bond you don't pay tax. Yeah. Another exercise question. You are considering an investment in a municipal bond that has an yield of after tax, you see RA equals to 6.5% annually because it's a municipal bond. Therefore, his yield is after tax. So if your marginal tax rate is 21%, then what is the tax equivalent yield on this bond, which means RB. Yeah, so I already gave you RA, which is 6.5. Here I'm asking you to calculate RB. Then just use the same equation, right? RA equal to RB times 1 minus T. So therefore, RB equals to RA divided by 1 minus T, right? So that's 6.5% divided by 1 minus 21%. Then you get 8.223%. So that's this. And then there's another exercise question. An investor is in the 28% federal tax bracket and pays a 9% state tax rate and 4% in local income taxes. For this investor, a municipal bond paying 6% interest is equivalent to a corporate bond paying how much interest? Yeah, so 6% clearly here is the municipal bond rate of return. So this is after tax, right? So this is after tax, and it's asking you, it's equivalent to a corporate bond paying how much interest rate level. So meaning that this one is asking you to calculate the before tax, right? Because corporate bond you have to pay tax. Therefore, the before tax equals to the after tax divided by 1 minus T. Here it's just the T is not directly given to you. You have to calculate. So T equals to the total of all this tax rate: 28% federal tax, 9% state tax, and 4% local tax. So in total, your tax rate is going to be 28 plus 9 plus 4, which is how much? That's 41%, right? So therefore, the before tax yield equals to 6% divided by 1 minus T. So 6% divided by 1 minus 41%. Yeah, so 6% divided by 1 minus 41%. Then the correct answer here is B, 10.17%. Okay, so I will stop here for today's class. The rest I'll leave it to our next class for chapter 6. Thank you all for attending today's class.